Okay, so now we're taking that next step and we're going to group the elements into different categories. And this eventually helps us do chemistry. So the one thing we have to remember is that it's not random when it comes to where things are placed on the periodic table. It's based on their chemical and physical properties. So our first family, which again, they're called groups or families. I call them families, so you'll hear me refer to them. We're talking about the up and down columns on the periodic table. So our first family are what we call alkali metals. So some of the characteristics are that they're super reactive metals, right? So very, very, as far as reactive, when we talk about that, chemically it means kind of unstable and they cause, some serious chemical reactions. So they're shiny, they're low density, and they easily give up one electron, which will make sense when we start doing electron configuration. So these guys will typically only match up with a group or another element that needs an electron. So it's a, like I say, puzzle piece. It only fits, or they only make compounds with usually what we call family sevens, but we'll talk about that later. So those are some of the characteristics. Family 2 are what we call the alkaline earth metals. These guys are still pretty reactive, not quite as much, and they have a little bit higher of a density. And these guys have 2 electrons in their outer energy level, which again doesn't make a lot of sense right now, but it will. So they typically will match up with another element that needs to have to, and so they form a compound. So then we have what are called the transitions. So we can see that the periodic table kind of dips down in the middle, and these ones kind of as they go across transition, so that's why we call them that. They are less reactive than family 1 and 2. And they, as you go across, their properties kind of vary widely, and they conduct electricity pretty well. These are our common metals that we often talk about. And as you look past that third family, it kind of dips down across for a while. That's what the transitions would be. So some of the common properties, things like mercury, that's used in thermometers. Mercury is actually not used in our thermometers at home anymore because it's carcinogenic. It's used in hospitals though because it's really accurate. So we use it more so you'll see it like in the hospital. And then gold, of course, titanium, iron. That picture on the right hand side there is a titanium hip, which some people have replaced as an artificial hip. And it's a really lightweight metal, which is good to have in the body if you need to have something like that. But not quite as reactive as the family 1s and 2s necessarily. And then iron, right, is kind of over towards the right. Fe is its symbol. And of course, we know it's in steel and things like that. So just some of the basics, right? Then we have the lanthanides and the actinides, which if you look towards the bottom, these we aren't going to spend a ton of time on, but they are the more radioactive, and they're unstable usually, but they kind of break it down at the bottom and open them up. Those tend to be a little less worked with as far as middle school chemistry goes, but you might see them a little bit more in high school. So then we go back across to family 13, starting with boron. These guys are reactive. Some of them are metalloids because they're near that zigzag line. They're solid at room temperature typically. Nothing too exciting about them. Then we have family 14, which starts with carbon. Again, some are metalloids, solid at room temperature, nothing too exciting. 15, family 15 starts with nitrogen, same thing. Some are pretty reactive, others are not, so we're starting to see a trend here. Then we have family 16, which starts with oxygen, which is pretty, of course, reactive. We know pure oxygen is dangerous to expose to a flame and reactive chemically. And there's only one metalloid in this family. And then we have the halogens, which are family 17. Now I mentioned that a little bit ago. I said family 7. Some periodic tables don't label the transitions with the family, so it would be family 7 on some periodic tables. But on our periodic table in our book, they're family 17. These guys have one electron needed in their outer shell. And so they're going to form with other metals to form things like chloride metals with chlorine, and they will often match up with family 1s because family 1s typically have an electron to give, and these guys need one. So It doesn't, like I say, make a ton of sense right now, but it will once we start looking at compounds. And these guys are kind of interesting too, because they are very, very common in a lot of compounds that we see. Then we have the noble gases. Now, a discussion we could have is why do we call these the noble gases? So we'll do that in a little bit. But these ones are the only ones on the periodic table that are what we call stable. And the reason they're stable is because their energy level has the number of electrons that it needs to become stable. So these are very rare in most cases because they don't form a compound. Most of the elements on the periodic table will form compounds. So these guys are what we say content chemically or stable. And so they don't usually form compounds. And that would be the very last family on our periodic table. So we'll ask this question in a little bit here. What is the connection with that nobility and the characteristics? So the only other one I want to talk about is hydrogen. It's sort of our anomaly. You'll see hydrogen often included as a family 1 or in that first group, right? But as I said earlier, if you were listening to some of the information that we've gone over, it is to the left of that zigzag line. So technically we say most of those are metals, but we know hydrogen is a gas, right? But based on its chemical makeup, it fits over there, but technically it depends on the periodic table you look at. Hydrogen is kind of on its own. So that's important. A lot of times you'll see it highlighted a different color just to kind of let that stand out. The reason it's placed over there is because it has that extra electron. And so it's ready to give one up and form a compound to make itself stable. So it's over there for that reason. Now we know hydrogen is flammable. If you guys remember reading the story about the Hindenburg, I think you read that as 7th graders in lit class. That's a great example of how dangerous some of these reactive some of these gases are, and it is explosive with oxygen. So it's very reactive. So it's placed over there. Okay, we'll come back together and talk about a little bit of this.